Hello and welcome to Mellow Labs. On today's episode, I added a Nozzle camera to my Prusa Mini, and after this short message from my sponsor, I'll show you how you can add one to yours. JLCPCB. With 19 years of experience and 5 state-of-the-art factories, it's no wonder that over 5.4 million engineers across 180 plus countries rely on their reliable and affordable services. Getting started is easy. Simply upload your Gerber files, get an instant quote, and place your order within minutes. It's just that easy. Whether you're prototyping or producing in volume, JLC PCB offers unbeatable pricing with 1 to 8 layer PCBs starting from just $2. But it's not just affordability. JLC PCB delivers premium quality with lightning turnaround times. Your boards can be ready within as little as 24 hours. All thanks to their fully in-house production process, which ensures quality control at every stage. And right now, there's an exclusive offer where you can get 6-layer PCBs for just $5 with $30 off of your first order. If you're ready to take your electronic projects to the next level, visit JLC PCB. The camera I'm using for this project is typically referred to as an endoscope camera, and you can pretty much pick them up anywhere for relatively cheap. In fact, for the first version of this project, I got the cheapest camera available so that if I did accidentally make it generate magic smoke, I wasn't too hard on myself about it. But the catch with the cheap endoscope cameras is that they're at best 480p, which is fine if you're doing some basic troubleshooting, but for a content creator, I need higher quality visuals to keep my retention metrics above 30%. So for my second revision, I went with a HD endoscope camera, which offers a whopping 720p. Which doesn't sound like a lot compared to the 4K I normally film at, but the extra boost in quality is definitely worth the slight increase in price. FYI, I didn't do all of the things in the order I'm telling you to do them. I'm doing them in the order in which I wish I would have done them to save myself some headaches, and the order I'll probably do them in if I have to do this again. To start with, let's cut off the camera. Give yourself about 15 to 30 centimeters from the camera module and just cut off the cable. It's going to make it a lot easier to handle later. This is probably a good place for me to mention. For some reason, I decided to get the longest cable available with the camera. You definitely don't need this. You only need it to be as long as it takes from your computer to go to your printer. I ended up just cutting mine down to about 1.5 meters, and it's perfect. Now that we've separated the camera from the cable, we want to remove the camera from the aluminum enclosure, and the easiest way I found to do this is to grab a pair of sharp wire cutters and start nibbling away at the plastic that's at the back of the camera module. We want to get in underneath the aluminum enclosure and peel it away from the plastic bit. The only thing that's really holding the camera in there is that plastic bit, which now that I think about it, you could probably just heat up the camera until the plastic bit melts and just pull it out. Quick interjection, I actually decided to try this on a spare endoscope because it sounded somewhat plausible, and it actually works. If you heat up the enclosure and with a pair of pliers pull on the rubber stopper at the back, the camera module just slides out. Obviously don't heat it up too much because you will probably desolder some components and do it at your own risk, but yes, you can do it this way.
Shit, that actually worked.
Now that we've got the camera out of the enclosure, we want to protect the circuitry a little bit. I'm doing this with some heat shrink tubing. Unfortunately, I didn't have the correct size heat shrink tubing, so the first one just slit right off. Luckily, there's a little known trick. If your shrink tubing is slightly undersized, you can leave it in a cold area and it will actually expand. That is completely not true. What I actually did was stretched out the tubing with some long nose pliers just a little bit so that it fits perfectly over the circuit board, and then I just shrunk it with some heat, and that worked perfectly. Next, we need to take care of the ring light. Unfortunately, it's not bright enough and it causes lens flares, so we're just going to remove it. It's attached to the camera lens with some double-sided adhesive. Simply peel it away from the lens with some tweezers and just cut off the little ribbon that connects it to the rest of the camera, and you're good to go. We'll be adding some better LEDs later on. Step 4.5. As the name might suggest, this isn't a full step, but more preparation for a future step. We want to make sure that we can focus the camera. The way we do that is by rotating the little lens that is on the front of the camera. On the HD versions, it spins freely. On the non-HD versions, I find that there's always a dab of glue on the threads, preventing it from moving. So you want to pick that off with a pair of tweezers and then move it back and forth with like needle nose pliers until it's relatively smooth. You don't actually want to fully unscrew the lens, because all that's going to reveal is the itty bitty sensor that is behind there, and you're kind of just risk damaging it. So don't bother. Now let's tackle the LEDs. I'm going to be getting my LEDs out of this light bulb I had laying around, and using a hot air station I'm heating up the diodes so that the solder melts and I can pick them off with some tweezers. It takes a little bit of practice. Luckily there's a lot of LEDs on here, and we only need 2, but you might want to grab a couple spare because the next bit involves some micro soldering. I have never been so turned on by gyroed infill. Now that we have the LEDs, we want to solder up a wire to the positive and the negative terminals of the LED. I'd recommend some thin silicon wire about 7 centimeters tall, and after they're soldered, we're just going to leave them aside and come back to them later. Moving on, we need a way to connect the camera back to the cable. Now, you can just solder it all back together, but personally I'd prefer a connector so that I can disconnect the camera module whenever I don't need it on the printer. So instead, I want to put in a connector. I was going to use one of these fancy ones from eBay, but unfortunately they didn't arrive in time. So instead, I made my own with some male and female pin headers that I had laying around. If anyone actually knows what these are called, please let me know. I made a connector that's 2x3, which gives me 6 pins, but there's only 5 wires. I highly recommend you use the spare pin as a key so that you know which way to plug in the wire each time. The way I did it is I removed the pin from the male connector and glued it into the female connector, so I have something to orientate myself next time I'm plugging it in. Now we're onto the mount, and luckily you get to skip the infinite loop of design, print, test, design, print, test, design, print, test. It took me to get to where I am. Because here it is, and you can get one yourself over on my Patreon. You can buy it, or if you're a Patreon member, you can get it for free. Well, it's not technically free because you're still paying the subscription fee, but you get some extra perks like early access to ad-free videos, your name on my supporter wall, and exclusive content available only to my Patreons. So, sign up today, link in the description. Currently, I only have a mount for the Prusa Mini because that's the only printer I use on the daily anymore, but I'm happy to expand my range. Just let me know what printer you'd like to see next down below the like and subscribe button, after pressing them of course. Now let's talk about filament selection. If you normally print in PLA and you print the mount out of PLA, it's very quickly going to start drooping and your nozzle will no longer be in frame. So typically you'd want to print the mount from a higher temperature filament than you normally print. In my case it's PETG, which is quite hot, so I'd have to use something like ASA. Unfortunately, I do not have the capabilities to print ASA, but I have a friend with a print farm who does. Joseph, who you might know as the person who throws cheese at my face until it lands square on my forehead, has a 3D printing business and has graciously offered a discount code for me and my viewers. That's right, if you head over to 3dprintmything.uk, drop in your STL files, he has a cool little preview for them and everything, select what filament and what color you'd like. He also has some multi-material options that aren't listed on the site, but just drop him a message through the contact field and I'm sure you guys can work something out. And then when you have everything you need, head over to the checkout page and use the code MELLOWLABS for a 10% discount. Now we have the camera, we have the LEDs, we have the mount. The only other things we need is 2 M3 screws and an M3 nut, and we can assemble the whole thing. Let's begin with the LEDs. The camera mount has dedicated holes for the LEDs for you to feed the wires through and run them all the way to the back. Now don't worry if your LEDs are different from the ones I have. Thanks to one of my community members, Get Lifty, the model is fully parametric, so all you have to do is adjust the size of the LEDs in the parametric menu and the model will adjust to fit those LEDs. Again, huge thank you to Get Lifty for doing that for me. I have no idea how parametric design works. Now we can put in the screw and the nut into their dedicated holes. Don't tighten them down too far until you've put the camera in and then tighten it. That will clamp the camera in place so that it doesn't move. Now we need to do some wiring. This bit is a little bit fiddly, but I believe in you. We're going to connect the LEDs in parallel, which just means we're connecting the red wire with the red wire and the black wire with the black wire, and then the black wire from the LEDs can go directly into the ground but for the positive wire, we actually want to use a resistor. We need to step down the voltage coming in from the USB, which in my case is 4.7 volts, down to the 3.3 volts that the LEDs will accept. So I'm using a 22 ohm resistor. By the way, do check your voltages before you go randomly connecting resistors. I thought mine ran at 5 volts. It doesn't, so I had to change the resistor midway through. So check the voltages and then adjust the resistor accordingly for the LEDs. And then just splice them in. It's not the prettiest looking thing, but with some heat shrink tubing, it's acceptable. I then used some thick gauge single core wire to wrap around the entire loom, mostly just to keep the cables from going all over the place and to add some rigidity. And now we are ready to mount it onto the printer with a M3 screw. Luckily, there is a pre-tapped hole on the heatsink right above the hot end that we can just screw the mount into. I modeled the mount to be bang on with the nozzle from that mount point. Unfortunately, the real world is the real world and it doesn't accept perfection, so it needs a little bit more adjustment from there. I recommend you lower the nozzle all the way down to the print bed and then adjust the mount so that it's about 1 millimeter off the bed so that it doesn't interact with any of your prints. In my case, the mount was a little bit twisted, so I used some hot air to warm up the mount and then I twisted it into position where the framing was bang on with my nozzle, and I just let it cool down so that it stays there permanently.
And the last thing to do is to adjust the camera's focus so that the nozzle is nice and sharp.
And that is how you add a nozzle camera to your 3D printer. Thank you very much for watching. Don't forget to like and subscribe, support me on Patreon if you can, and I'll see you on next week's live stream. Goodbye.